And it's one that, a lot of students struggle with because you're having those two variables. All right, so the next one is understanding like the end behavior for, rational functions. So I'm just going to do kind of a little bit of like a calculus approach, or not really a calculus approach, but just kind of one that's just kind of gets into the idea of like something that we'd want to get into a little bit of the higher end is just understanding how, graphs grow, right? So, if you just think about numbers, for instance, if I had like x squared, right? So if I keep on plugging numbers in for x, they're going to keep on getting larger and larger, right? And again, when we're thinking about numbers, let's just pick 1, 2, 3, 4. Okay. So if this is my function x squared, and if I plug in 1, plug in 2, plug in 3, plug in 4, you can see those numbers are going to keep on going larger and larger and larger. So that's why, like if these represent my x values and these represent the y values, right? Like y equals, then you can see that as x gets larger and larger, the y value is going to get larger and larger, right? So as x is approaching infinity, you can say y is approaching infinity, or that m behavior as x is going to the right, you can see that y is going to infinity. So let's go and take that a little bit further and say, all right, why don't we just go ahead and take a look at some examples here? So what if I had x squared over x plus 1? All right. So think about this. If you keep on plugging in numbers, and for instance, let's get up to like 3. If I plug in 3, that's going to be 9 divided by 4, right? And then if I do 4, that's going to be 16 divided by 5. And so what happens is this top is growing faster than the denominator. So since it's growing faster in the numerator than the denominator, as x keeps on getting larger and larger, you can see that this graph is going to keep on getting larger and larger. So even though it's a rational function, since the numerator is growing faster than the denominator, that's why the end behavior is going to be going up to infinity. Now, this is where I'm going to kind of end. I'm not going to get too much calculus. I'm just going to focus on polynomials. How do we know if a polynomial is growing faster in the numerator and denominator? Well, for polynomials, we're just going to look at the degree. So obviously, calculus, we get into a lot more advanced types of functions, and we kind of talk about their growth. But for here, we'll just kind of stick with polynomials. If the degree in the numerator is larger than the degree in the denominator, we know that the numerator is going to be growing faster. Well, what about, let's flip it over. What about if the degree in the numerator is smaller than the degree in the denominator? Well, that means the value in the denominator is growing faster, right? Now, what happens when you have numbers in the denominator keeps on getting larger and larger? Like for instance, let's, if I had, 1 half, 1/3, 1/4, right? 1/5. And again, just imagine if those numbers are being squared, like they're going to get smaller and smaller and smaller. So therefore what happens is as my denominator is getting larger and larger and larger, what's happening is my end behavior is approaching 0. So I'll just write this as x approaches infinity, y approaches infinity. And as x approaches infinity here, y approaches infinity. I'm sorry, y approaches 0, right? So as we keep on getting numbers getting larger and larger and larger in the denominator, that's actually going to be approaching 0. So again, whenever the degree is larger in the numerator than the denominator, we're going to be approaching 0. And then the last example that we talked about is what about if they're actually the same? What if this was x squared plus 1 over x squared? Okay, what actually would happen here, right? And really, if you just keep on plugging in the numbers, like for instance, 4, right? That's going to be 17 over 6. And then you're going to have, you'd have, let's do 3. So it'd be 10 over 9. And then it'd be 17 over 6. And you keep on getting larger and larger and larger numbers. They're almost going to be exactly the division product, like the division of themselves as they keeps on getting larger and larger. So when you have the degree equal to each other, they're going to be approaching 1. So therefore, as x approaches infinity, y is going to approach 1. Now, why is it 1? Well, that is the leading coefficient of the numerator over the leading coefficient of the denominator. So really, the answer to my question, the answer to the student's question is identifying end behavior would just really be, especially if dealing with polynomials, is really just to find the horizontal asymptote. Obviously, for the first two questions, you have the horizontal asymptote. If 0 or in 1. In the first example, there is no horizontal asymptote. So therefore, you just want to be able to determine, is this numerator going to be going positive Or is it like negative, right? Where it's actually going to be going to negative infinity. So not getting super advanced because they always kind of told me to talk about it. So I'm not really sure exactly where they're maybe having